Good day! I'm Mateo Navarro,
And Joylene C. Agman.
and today we are going to tackle about mobile app testing and debugging. So we have two things that we are going to tackle. First is the testing strategies for quality assurance, and lastly, debug and troubleshoot common app issues. So first, we are going to tackle about testing strategies for quality assurance. Testing strategies for quality assurance refers to a set of systematic approaches and methodologies employed in software development to ensure that the final software product meets specific quality standards and delivers a positive user experience. Quality assurance in software development involves systematically checking and validating the software to identify and rectify defects, bugs, and inconsistencies. Testing strategies play a pivotal role in this process.
Here's a breakdown of the key elements in the term testing strategies for the quality assurance. Testing is a fundamental activity in software development where the primary goal is to assess the behavior and functionality of a software application. It involves executing the software under controlled conditions to identify any discrepancies between its expected and actual outcomes. Testing is not limited to checking for any defects or bugs. It also verifies that the software functions correctly, meets specified requirements, and delivers the intended value to users.
Testing strategies are systematic and planned approaches that guide the entire testing process. They help in organizing testing efforts effectively and efficiently. These strategies encompass various aspects, including what to test or test scope, how to test or testing techniques and methods, when to test or testing phases, and who will perform the testing. Developing a testing strategy involves considering factors such as project goals, budget, timeline, and available resources.
Quality assurance is a comprehensive process that goes beyond testing alone. It encompasses all activities and practices aimed at ensuring that a software product meets predefined quality criteria. Q involves a holistic approach to quality, including designing processes that produce high-quality software, conducting code reviews, adhering to coding standards, and addressing non-functional aspects like performance, security, and scalability. Q seeks to prevent defects from occurring in the first place, in addition to identifying and addressing defects through testing.
So now let's proceed to primary goals of testing strategies for quality assurance. Identifying and addressing defects early. One of the key objectives of testing is to catch and rectify defects and issues as early as possible in the software development life cycle. Early defect detection reduces the cost and effort required for fixes.
Ensuring functional compliance. Testing ensures that the software meets its functional requirements and behaves as expected. It validates that the software performs the intended functions accurately.
Verifying reliability and performance. Quality assurance testing strategies aim to verify that the software is reliable, secure, and capable of performing well under various conditions. This includes assessing its stability, security against threats, and ability to handle heavy workloads.
Enhancing user experience. QA strategies focus on improving the overall user experience by minimizing the likelihood of issues and bugs. This involves testing the software from a user's perspective, ensuring it's user-friendly, intuitive, and free from usability problems.
So now let's proceed to common testing strategies that fall under the umbrella of quality assurance. First is manual testing. This involves human testers manually executing test cases to evaluate the software's functionality, usability, and overall quality. It is often used for exploratory testing and assessing user experience.
Automated testing. Automation tools and scripts are used to execute predefined test cases. making it efficient for repetitive and regression testing. Automated tests can be run quickly and consistently.
Regression testing. This type of testing ensures that the new code changes do not introduce defects or negatively impact existing functionality. It helps maintain the integrity of the software.
Performance testing. Performance testing assesses how the software performs under different conditions, such as high user loads or stressful situations. It ensures the software remains responsive and performs optimally.
Security testing. This strategy focuses on identifying vulnerabilities and weaknesses in the software that could be exploited by malicious actors. It's crucial for protecting data and maintaining the software's integrity.
User acceptance testing or UAT. UAT involves end users or stakeholders testing the software to verify that it aligns with their requirements and expectations. It's the final check before the software is released to ensure it meets user needs.
Continuous integration and continuous testing or CI or CT. It involves integrating testing into the software development pipeline, allowing for automated and continuous validation of code changes. It catches issues early in the development process, supporting rapid and reliable releases. Overall, the goal of testing strategies of quality assurance is to enhance the software development process, reduce the risk of post-release defects, and ensure that the final product meets or exceeds user expectations, thereby maintaining the software's reliability, security, and performance. So next, we are going to tackle about debug and troubleshoot common app issues.
It refers to the process of identifying and resolving technical problems or errors that can occur in a software application. Debugging and troubleshooting are essential activities in software development and IT support, aimed at ensuring that an application functions as intended and delivers a smooth user experience. Let's break down this concept further.
First is debugging. Debugging is the process of identifying and correcting errors of defects in a software application's code. It involves locating the root causes of issues such as software bugs or unexpected behavior and making necessary code modifications to fix them. Developers often use debugging tools like Integrated Development Environment or IDE, debuggers or log files to trace the flow of code execution and find problematic areas.
Second, troubleshooting. Troubleshooting extends beyond code-level issues and focuses on identifying and resolving problems that may affect the application's functionality or performance. It encompasses a broader range of issues, including configuration problems, compatibility issues, network or connectivity problems, and more. Troubleshooting often involves a systematic approach to isolate and resolve issues, which may include checking logs, monitoring system resources, and testing various components of the application stack.
Next, we are going to tackle about key aspects of debug and troubleshoot common app issues. First is common app issues. It refers to recurring problems or errors that are frequently encountered when using a software application. These issues can include application crashes, incorrect behavior, slow performance, connectivity problems, and user interface glitches, among others. Identifying and addressing these common issues is crucial for maintaining the functionality and user satisfaction of the application.
Next is identification. Identification is the process of recognizing and pinpointing a specific issue or problem within the application. It often starts with the gathering information from users or error reports to understand the symptoms of the problem. Reproducing the problem in a controlled environment is a key step in identifying the issue, as it allows developers or support teams to observe and analyze what went wrong.
Isolation. It involves narrowing down the root cause of the issue once it has been identified. This step requires examining different components of the application to determine whether the problem lies in the code, configuration, data, or external dependencies. Isolating the issue helps prevent unnecessary changes and ensures that the right area is targeted for resolution.
Resolution refers to the process of fixing the identified issue or problem. It can involve various actions, such as modifying the application source code, adjusting configuration settings, updating libraries or dependencies, or applying patches. The goal is to implement a solution that eliminates the issue and restores the application to its intended functionality.
Lastly, testing. Testing is a critical step in the debugging and troubleshooting process to verify that the resolution effectively addresses the issue. It includes testing the application under various scenarios to ensure that the problem no longer exists and that the fix does not introduce new issues. Regression testing, which checks that existing functionality remains intact, is a common part of this phase. So now, let's proceed to common techniques and tools used in the process of debugging and troubleshooting.
First is debugging tools. Integrated Development Environments, or IDEs, provide tools such as breakpoints, watches, and step-by-step execution for examining and debugging code. Profiling tools can help identify performance bottlenecks.
Next is logging. It involves the use of log files or log statements within the code to record information, errors, and events during application execution. Analyzing log data can provide insights into the sequence of events leading up to an issue.
Error messages and stack traces generated by the application can provide valuable information about where and why an error occurred.
Monitoring tools. It helps track system resource usage, performance metrics, and the behavior of the application in real time. They are particularly useful for diagnosing performance-related issues.
Documentation and knowledge base. Reference materials, documentation, and knowledge bases can provide guidance on troubleshooting known issues or common problems.
Lastly is user feedback. User feedback, including bug reports and user support interactions, can provide valuable context and information about issues experienced in the field. In summary, debug and troubleshoot common app issues involves the systematic process of identifying, isolating, and resolving typical problems or errors that can occur in a software application. It's a critical skill of software developers, IT support teams, and anyone responsible for maintaining and ensuring the functionality and reliability of software applications. Effective debugging and troubleshooting can lead to improved application quality and a better user experience.